Storing keys with associated values in Hashmaps. The last of our common collections is the Hashmap. The type, Hashmap KV, stores a mapping of keys of type K to values of type V. It does this via a hashing function, which determines how it places these keys and values into memory. Many programming languages support this kind of data structure, but they often use a different name, such as hash, map, object, hash table, dictionary, or associative array, just to name a few. Hash maps are useful when you want to look up data not by using an index, as you can with vectors, but by using a key that can be of any type. For example, in a game, you could keep track of each team's score in a hash map, in which each key is a team's name and the values are each team's score. Given a team name, you can retrieve its score. We'll go over the basic API of hash maps in this section, but many more goodies are hiding in the functions defined in Hashmap KV by the standard library. As always, check the standard library documentation for more information. Creating a hash map. You can create an empty hash map with the new and add elements with insert. In listing 820, we're keeping track of the scores of two teams whose names are blue and yellow. The blue team starts with 10 points and the yellow team starts with 50. So we have use std collections hash map. Okie doke. Let's put this in a function called I think I'm gonna go off the rails a little bit and say let mute crane hashmap new crane dot insert. Okay. String from honor. Okay, so that should be the key, and the value is yep, there's me and my right impulse. Actually, I had to look something up, and this needs to be Kakita. Changing a word. Kakita. And let me give honor a value. Will be 50. And then do I just get rid of that, and then I do this, and then that. A little bit too big. Oop. Come on. Oh, wait. There we are. We can expand this some too as well. Let's give me some more space. There we go. And this is actually not right either. This should be duelist. Okay, and then, yeah. Okay, and then this is also duelist. Right. So then I guess, okay, so then yank it, put it, delete that. So now we have string from, what's next, glory? It is. So now glory will be 44. Last but not least, we will have, excuse me, status, which is 35. Note that we need to first use the hash map from the collections portion of the standard library. Of our 3 common collections, this one is the least often used, so it's not included in the features brought into scope automatically in the prelude. Hashmaps also have less support from the standard library. There's no built-in macro to construct them, for example. Just like vectors, hashmaps store their data on the heap. This hashmap has keys of type string and values of type I32. Like vectors, hashmaps are homogeneous. All of the keys must have the same type, and all the values must have the same type. Another way of constructing a hashmap is by using the collect method on a vector of tuples, where each tuple consists of a key and its value. The collect method gathers data into a number of collection types, including hashmap. For example, if we had the team names and initial scores in 2 separate vectors, we could use the zip method to create a vector of tuples where blue is paired with 10 and so forth. Then we could use the collect method to turn that vector of tuples into a hash map, as shown in listing 812. Okay, it's time to move this out of main, I do believe. This will be, we'll just call it Kikita. And then we do need a main function, f in main. And we will call Kikita. Now another function will be this one will be Shosra. Okay. Do I have to use? No, I don't. Okay, so let. Okay. We'll say let. Let what? Numbers. No. What are these called? How about let's call it values. So let values equal vec macro string from am I gonna have them all to begin with? Here they're starting with 2 of them. I guess so. So we will say string from honor, and then okay, so visual, we'll go to there, and a yank it, and and put it. Hey, I've done a thing. Okay. But is it saving time? So string from, yeah, I've done it again. A string from honor, string from glory, and, oh well. I need to learn about registers. And string, yeah, from status. Guess I gotta make it smaller. Sorry. Okay, what have I done wrong? Need a semicolon, right? Yes. Okay. Then I guess I can split that. Let's see. We'll go here and say replace that with a space. I mean a line break. Then we can replace that with a line break. That sure does look funny. I don't think that was the right choice. Okay, so I guess that's not supposed to be there. And then we'll come in and put a line break there. Okay, this looks better. And I didn't get yelled at. Okay, what's next? Let initial scores equal vec 1050. Okay. So let me get my numbers in a row here. The Shosra Infiltrator School gets honor is 30, and the Shosra family has glory 40. And the Scorpion clan starts with status 35. Right? Yes. Alright, so delete that. Oh, good. That'll do. So now we can say, let say value, gosh, should I just call this keys? Yes, I should call this keys. Keys. Ha! That's funny because I needed a word, and the word I found that I wanted to use should really be for this vector, values. So values will be vec bang, and then I need okay, honor first, so we got 30, and then glory status, so 40, 35, 35, and then let, so this is our hash map coming in, so this will be Shosra Infiltrator is a hash map. We got a underscore and a space and an underscore. Fight the impulse. Don't do it. Okay, and then equals What do I need here? Keys dot iter zip and whoa, that's okay. So we'll say keys dot iter and then dot zip, and we are zipping values dot iter, right, and then we are going to collect them. We've done it. The type annotation hashmap underscore underscore is needed here because it's possible to collect into many different data structures, and Rust doesn't know which you want unless you specify. For the parameters for the key and value types, however, we use underscores, and Rust can infer the types that the hash map contains based on the types of the data in the vectors. Yeah, so let me look at this. We've got let, all right, so let keys equal a vecbang, and the three keys are honor, glory, and status, and they are string type. Now we say let values equal 30, 40, 35, and they need to line up with those keys, so I suppose they will. So let Shosro infiltrator, which is a half map, a hash map, be keys iterated. So I guess sort of apply the keys, or no, dot iter. So go through and do this for each of the keys in order. And then the thing that we're doing is let's work from the back. So first we're going to collect them, and we're collecting them into a hash map. Then we're going to last we collect them. Because it seems like sometimes it goes the other way. So we'll zip the values iterated. So what does zip do again? So the collect method on a vector of tuples. So the collect method on a vector of tuples. So the team names, or keys in a vector, and then we use zip to create a vector of tuples where honor is paired with 30 and so forth. Then we use the collect method to turn that vector of tuples into a hash map. Okay. Hash maps and ownership. For types that implement the copy trait, like I32, the values are copied into the hash map. For owned values like string, the values will be moved, and the hash map will be the owner of those values, as demonstrated in listing 822. Okay. Make a new function called, oh, hello there. I noticed that. So a new function will be called trash. Let field name equal string from fave call. Let field value equal string from maybe like that. It's a pretty good one. And then let mute map equal Hashmap colons new and then map dot insert field name. I remember back when I used to use text editors that had features like completion, field value, bam. Oh hey. Okay, so I thought I was gonna get a compiler error. So field name, string favorite color, field value. Did I like grossly misspell something, or I just didn't put it didn't try to run this. That must be it, I guess. Trash. Bam. Okay. We aren't we aren't able to use the variables field name and field value after. Did I do something with the? Try using them. Oh, I forgot to use them. Yes. Okay. Got it. So print line. That, and then I mean it's a string, so it has it should display, I think. And let's do field value. Haha. Borrow of moved value, field value. If we insert references to values into the hash map, the values won't be moved into the hash map. The values that the references point to must be valid for at least as long as the hash map is valid. We'll talk more about these issues in the Validating References with Lifetime section in Chapter 10. Okay. Accessing values in a hash map. We can get a value out of the hash map by providing its key to the get method. So where is my get method? Let team name equals string from blue. Okay, so we'll say let Okay, let crane stat equal string from honor. Is that the one? Let me check. It is not. It is status. So we will let crane stat equal string from status. Let should I just call it key and value? Yes, I should. It's funny because I used to complain that they would name oh, what? Oh, I used to complain about them using variable names. Ouch. That were confusing to me. Well, okay, so we're gonna let value equal right. Kakita dualist dot get a reference to key. Here, score, or I said value, will have the value that's associated with the blue team. Okay, I'm just gonna read the text. Here, score will have the value that's associated with the blue team, and the result will be some reference to 10. The result is wrapped in sum because get returns an option reference to v. If there's no value for that key in the hash map, get will return none. The program will need to handle the option in one of the ways we covered in Chapter 6. We can iterate over each key value pair in a hash map in a similar manner as we do with vectors, using a for loop. Let's find out if me naming my variables key and value is going to mess things up here. So for key, comma, value in reference to Kakita. Why did I use such a long word? Dualist. Okay. And then do this. Oh, golly. Print line. That. One of those. A couple of those. Oh, that's one too many. Then, yeah, I messed up. Okay, key value. This will work just fine. Let's see what we get. Crun. Compiling. Alright. Status 35, honor 50, glory 44. Lovely. This code, oh, I see that. This code will print each pair in an arbitrary order. I wonder why it's arbitrary. Updating a hash map. Although the number of keys and values is growable, each key can only have one value associated with it at a time. When you want to change the data in a hash map, you have to decide How to handle the case when a key already has a value assigned. You could replace the old value with the new value, completely disregard the old value. Oh. You could keep the old value and ignore the new value. Wait, okay. You could replace the old value with the new value, completely disregarding the old value. You could keep the old value and ignore the new value, only adding the new value if the key doesn't already have a value, or you could combine the old value and the new value. Let's look at how to do each of these. Overriding a value. If we insert a key and a value into a hash map and then insert that same key with a different value, the value associated with that key will be replaced. Even though the code in listing 824 calls insert twice, the hash map will only contain one key value pair because we're inserting the value for the blue team's key both times. Alright, so let's say my okay, I'm going to change this to glory. I think I just looked at it. Glory, yes. Okay, so I want to see what his glory is after I change things. And so that means, hey, all I had to do was change glory, and that's the one it'll go get. Cool. Okay. So we will I'm regretting how long that hash map name is. Okay, so we have Kakidu. Yes, I see. Oh, I see. I see now. Don't comment below about it. Insert. You know what? Fine. We will yank and then put, and then glory goes up by 5. So that makes this 49, because my Kakita duelist is a clan, he's a company man. So we're gonna run this and see what we get. Yeah, that's right, son. Why? Yeah. So they have the debug. What do you call it? Yeah, debug. They're using debug formatter here. I'm not going to change anything. Okay. This code will print blue 25. The original value of 10 has been overwritten. Only inserting a value if the key has no value. It's common to check whether a particular key has a value, and if it doesn't, insert a value for it. Hashmaps have a special API for this called entry that takes the key you want to check as a parameter. The return value of the entry method is an enum called entry that represents a value that might or might not exist. Let's say we want to check whether the key for the yellow team has a value associated with it. If it doesn't, we want to insert the value 50, and the same for the blue team. Using the entry API, the code looks like listing 825. So scores.entry, string from yellow, or insert 50. Interesting. The OR insert method on entry is defined to return a mutable reference to the value for the corresponding entry key if that key exists, and if not, inserts the parameter as the new value for this key and returns a mutable reference to the new value. If the key exists. if that key doesn't exist, it inserts the parameter as the new value for this key. So I guess it creates the key as well. So entry, okay, so entry sounds like it's going to do both things. So we will enter yellow, insert 50, blue, insert 50. So here we already have scores, insert string from blue 10. So what is this doing? This is only inserting a value if the key has no value. Yeah, but there's no key. Only if, okay. Running the code in, what is it? This technique is much cleaner than writing the logic ourselves, and in addition, plays more nicely with the borrow checker. Running the code and listing 825 will print yellow 50, blue 10. The first call to entry will insert the key for the yellow team, right, with the value 50, because the yellow team doesn't have a value already. The second call to entry will not change the hash map because the blue team already has the value 10. But what if there's a key but it doesn't have a value? Can we have a key without a value? Let's play with our Shosuro. Oh, that might be more difficult because, okay, wait a minute now. So status, this is the one that comes from, well, no, I don't play with glory. So what if can I make this be an underscore and then it won't have a value for glory? Whoa. Ugh. Sometimes I push the right buttons. Yes. Delete. Underscore. And here we go. Oh. No rules except the token underscore. Huh. And it's a macro, so I don't know. I don't know about that one. I guess I can just give it a... All right. Let's go ahead and make a new one. Yeah, let's do that. And I'll see if I can remember how to do that. We will have a main function called, a function in main called, how about, since this is Rust after all, we will have a Caillou. And of course there is no, oh, man. I guess I could change that so it doesn't always check this business. Or let me just go ahead and create my function Caillou. Function Caillou. No arguments, or no parameters, and that. Happy? Yes. So that's not what I wanted. This, that, this. Okay, so our Caillou function will have the Hashmap engineer. I can type that word pretty fast, so that should be fine. So our engineer, I guess we got a let, right? All right, so we will say let engineer. Oh no, I'm not gonna, yeah, I'm not gonna do that. How do we want to do this? We'll go with the hash, let's do hashmap new. So we'll let mute engineer equal hashmap new, and then engineer dot insert. Yeah, but can I insert? Okay, so I feel like they led me astray. It seemed to me, yeah, check it out. Only inserting a value if the key has no value. So that makes it sound like you can have keys that don't have values. It doesn't seem like, okay. It's beep boop. Yeah. I don't see whether you can have, I don't see whether you can have a key without a value. Okay, updating a hash map, overriding a value, only inserting a value if the key has no value. That's what we're going to do. So we have let mute engineer equals hashmap new, and then engineer dot, we will do honor and glory first and then status last. Okay. I have the working memory of a fish, so I will be coming back up here to look at this one more time at least. Okay, before I jump away, let mute engineer equal hashmap new. Engineer dot insert string from honor is 50. I'll say engineer dot insert string from glory is 44, and then I'll stop doing that and do the other thing. Here we go. Let in mute, yes, a mute, I remembered a thing. So let mute engineer I forgot already. Can you believe this? Okay, I'm cheating. It's right there on my screen. So let mute engineer equal hashmap and new, and then we will say engineer dot insert yeah, so we'll now string from, I can't remember the order of them. That's not on the screen. String from honor, and I'm gonna have to look it up anyway. What do we got here? Honor glory status, yes. So string from honor, and Caillou engineer has honor of 40, right? And then, do I want to insert anything else? Maybe, well, let's see. Maybe I can do the next one as entry, as using the entry method. Updating a value based on the old value. Oh yeah, there we go. That is what I will do. Because which one grows? Which one did I change before? I updated glory because I decided that my Kakita duelist was philosophically aligned with his clan, and so he got some extra glory. So we will leave that one for, oh no, I guess we'll go ahead and put that in now. So alright, honor, and then yeah, because we're going to update it, so we do need an old value for that. Engineer insert string from glory. So I'm going to check the Caillou family's starting glory. And I didn't pause it this time. You can hear it. Listen to me flip pages. Can you hear it? Flip. Oh, there it is. Caillou starting glory is 40. Well, that's handy. Okay, now it's time for the entry function. So we will say, ooh, I'm gonna, oops. How did I come back? Okay. Yeah, we will go ahead and yank. I just added this in my NVim configuration. I did something and I haven't tried it yet. So let me try. I'm going to do capital Y to yank from my cursor to the end of the line. And it works great. Not that that's what I want, but you know. So yank, yank. And we will have, we want 2 of them, right? Sure, why not? Oh, I did that. Oh! Yank, yank, put. So now, let's say, what is it? Entry. Entry. So if there is a string honor, then give it a, excuse me, give it a 30, right? Because it's going to ignore that. Ugh. Me and my... Look, you know what? I'm not proud of it. But that's what I just did. So now I got to figure out how to get rid of that. Running on save. No, I want it to run on save. I just got to stop writing so much. So we have string from... Oh, or insert. Got it. So string from honor... Oh, right. String from honor, comma. Oh, here we are. Okay, so we have. Here we go. Y S parentheses. Maybe I was too slow. I'm working on Vim Surround. Okay, here we go. We're gonna do it again. Y S parentheses. I evidently typed G instead of Y. No, I don't know what I did. Y, S, parentheses. Enter. Yee. Oh well, for another day. So, this is going to be now string. Okay, let me catch up to myself. String from... Oh, I see. Yeah, okay. So after this is where the dot or insert goes, and then I will give it 30, and I want it to return... I don't want it to do that, but I'm trusting that it won't. Okay, so now we're gonna go with change inner that thing to status. And how much status does the crab clan get? Flipping pages, 30. Nobody appreciates the crab clan. So change that to a 3. And now we want, let me go gank this, do I get to, yeah, that works, right? So we will yank, how many? 2 down, and then we'll go down to the bottom. And that's not what I really wanted, but whatever. Okay, so paste. So for key value, yeah, I know. For key value in reference to engineer. All right, and then Caillou. Great, so now we can run this and it should give us something to look at. Yeah, okay, so I need more in my prints. So first of all, If you've been paying attention, you knew this was coming. So we're going to do that, and then so a new line, and then we'll say Kakita duelist, and then let me envision this in my mind. We will have it will say Kakita duelist. I know I want a new line. I want something here like a colon. Do I want a colon? Sure. You know, I bet I could have, that's fine. Am I spelling duelist correctly? Probably. Alright, so now we're going to come in the Caillou engineer and say, give me a new line, and Caillou engineer, colon, new line. Now we will crun it. Oh. Interesting. So we have Kakita duelist, status 35, glory 44, honor 50. So the engineer should have honor 40 and glory 40 and status 30. So it looks like it did not update honor as promised. Great. So when this says only inserting a value if the key has no value, I'm curious whether it's possible to have a key that doesn't have a value, and if not, then perhaps this should say something like only inserting a value, only inserting a key value pair if there is no key of that name or something. Okay, far have I gone? Updating a value based on the old value. Another common use case for hash maps is to look up a key's value and then update it based on the old value. For instance, listing 826 shows code that counts how many times each word appears in some text. We use a hash map with the words as keys and increment the value to keep track of how many times we've seen that word. If it's the first time we've seen a word, we'll first insert the value 0. Well, this is interesting. So let text equal hello world, wonderful world. Let mutable map be a new hash map. For word and text, we'll use the split white space. I might have said macro earlier when I meant to say method. Yes, for word and text, run split white space, and then for word and text, split white space. Got it. So in order to iterate over words and text, we have to split out white spaces, I suppose. Let count equal map.entry word dot or insert 0, and then dereference count update plus equals 1, so add 1. Okay, so let me see if I understand this. So working on map, we're going to run the entry method, and entry will take excuse me, its parameter as a word, right? So a word is anything split by white space. So that will be the key. Hello will come in as a key. And then it says or insert 0. Do you know that I think over here I forgot to use entry twice? I only used it once. It didn't illustrate the difference very well, did it? So let me come back and say change word to entry. And it's a string from status. Status will be 30. Okay, so delete till the close paren, and then dot or underscore in, oh, come on, insert, and it was 30, right? I'm not robbing the Crane clan of their status. They don't have a lot anyway. Okay, coming up to the top, I think we don't really need this right now. No, we certainly don't. Oops. Okay. Let me crun this and see what I get. Right, okay, so honor 40, glory 40, status 30. And that sounds right. Yeah, okay, it works. I mean, we all knew it worked, but now we see it working. So here, so map.entry is taking word. So for instance, first it will take hello in the first iteration. Well, you know, who knows, because the other iterator, the other time I ran some iterator, it went in an arbitrary order. But anyway, so when it comes to hello, okay, so when it comes to hello, it will map dot entry. It will enter. Okay, hello. Create a new entry, because right now there's nothing in the hash map. It's going to create a new entry. And what? And then it will insert a 0 for that entry, and then immediately will dereference count, and then change the value of count by increasing it by 1. So then what happens when it gets to, so then world coming in the first time is created as a key with the value set to 0, and then the value is the count of them. Yeah, the value, which is count, is increased by 1. Same thing with wonderful. And then it goes to world again. And here it says one world for word in text split white space let. So the word here is world. So we're coming in for world. First we will let count equal whatever this is, or nothing. Oh no, don't do anything, because it's gonna say, whoa, we've already got a world in there. Don't do that. Then we come down and it says, all right, add 1 to the count. I wonder if this is, I mean, this is interesting. Okay. This code will print, well, let's do it. Okay, so this is not, okay, this is a little bit more complex than what I was expecting. So now I need to, we'll say, let me think through how to make this work. I don't know if I need to iterate. So how is it that how am I going to do this? I guess we'll iterate. Let me read what they got here. Okay, this code will print world 2, hello 1, wonderful 1. the OR insert method actually returns a mutable reference. So reference to mut v to the value for this key. Here we store that mutable reference in the count variable. So in order to assign to that value, we must first dereference count using the asterisk. The mutable reference goes out of scope at the end of the for loop, so all of these changes are safe and allowed by the borrowing rules. Alright, so I don't think I want to use a for loop. So I have come back to the processing a guess part of the guessing game thing from chapter 2, I guess. I don't know what chapter I'm in. Chapter 2, programming a guessing game. So I think what I'm going to say is we'll have it print something like, what do you think about your clans? What about it, huh? And then I'll get a input from a user, and then I will match it to something and let that be how I determine. I don't know, I'm just messing around. So use standard IO, all of it apparently. Okay. Oh no, right, because I'm. Why is there a colon there? Okay, not all of it. Come on, man. You know this stuff. Golly. Okay, so we will say we'll print a line, and of course I gotta have my new line up front and give me some space. And this is from question what? Question. Okay, I'll pause it. Alright, so since we're just in Caillou, we will say, will you defend the wall that you've built? Okay, will you defend the wall? And now, if... Alright, so now we need... No, go away. Stop. Cut it out. IO stdin dot read underscore line. Ooh. I guess I need to... Yeah. And we'll say mutable. I bet it doesn't have to be mutable. No, it does. It does. Reference to mutable answer, and then dot expect dang. Okay. I am fighting the urge to hit :W. So now we will say let immutable answer equal string new. Ooh. Okay, how'd I do? Good. So now, let's test this out a little bit. And now we're going to, yeah, oh, there we go. You guessed guess. All right, I will copy and paste. Paste. Right, okay. Here, and let's have this. Oh, right, of course. duh. I knew that. Answer. Answered. So we're just crabbing, right? Yeah, okay. Caillou and Crun. Oh. That's not what I expected. So I didn't, I didn't guess. Okay. So let mute answer equal a new string, print we defend the wall. And after that, excuse me. But I didn't give me a chance to answer. Oh, crap. Okay, well, it works if I'm out of Vim. So, who knows? Right. Okay, so now I will just use an if. Yeah, I'll just use if. I don't think I even need a then. So, here we'll say if answer equals yes. Wait, okay. String from yes. Right? String, if it equals, Do I have to say string from yes? Well, let's try it. String from yes. If answer equals string from yes, then we will do the thing. Now what we want to do is, let me go back to the chapter we were in, which is Ocho 3. Okay. And we want updating a value based on the old value. Yes. So if answer is string from yes, we will okay, then we will excuse me. So update a value based on the old value. Okay. Need to access the value for status. Okay, so we'll try using the get method, but I'm not sure whether in the scope of the if statement it'll have access to it. Let's try. So if the answer is yes, then we will let key equal string from, right. Sure do a whole lot of string froming. String from status. Oops. So I guess I got some business out there. Okay. I did it. I did it again. Oi. Okay. Mismatched types, huh? If answer is string from yes, let key equal. Oh, yeah. Because I didn't. Just have to have the else, right? Do I need it? No, because we have. Right, I have to what is it? Unwrap? Yeah. Dot unwrap. Is that good? You like that? No. No method named unwrap, huh? I'm making it worse. Oh, I think it's a reference to, yeah. So delete to, yeah, okay. So delete to that right there. And then, is it gonna let me delete surrounding parentheses? Let's try. D S parentheses. No, didn't work. Okay. So whack that and that. If answer up. Okay. So if answer, which is a mutable reference to a string. Oof. All right, well, I noticed one problem I was having. I do believe that, do I have two if statements here? What is going on? Anyway, I am gonna read the rest of this and then be done with this video, even though that was a whole lot of nothing. A whole big pile of fail over here. And really what I wanted to do, it would have been easiest just to use insert again and overwrite the value. But let me read the rest of this. Hopefully I'll upload a video with this fixed. So, hashing functions. By default, Hashmap uses a cryptographically strong hashing function that can provide resistance to denial of service attacks. This is not the fastest hashing algorithm available, but the trade-off for better security that comes with the drop in performance is worth it. If you profile your code and find that the default hash function is too slow for your purposes, you can switch to another function by specifying a different hasher. A hasher is a type that implements the build hasher trait. We'll talk about traits and how to implement them in Chapter 10. You don't necessarily have to implement your own hasher from scratch. Crates.io has libraries shared by other Rust users that provide hashers implementing many common hashing algorithms. Summary. Vectors, strings, and hash maps will provide a large amount of functionality necessary in programs when you need to store, access, and modify data. Here are some exercises you should now be equipped to solve. Given a list of integers, use a vector and return the mean, median, and mode of the list. Convert strings to Pig Latin. Keep in mind the details about UTF-8 encoding. Using a hash map and vectors, create a text interface to allow a user to add employee names to a department in a company. For example, add Sally to engineering or add Amir to sales. Then let the user retrieve a list of all people in a department or all people in the company by department sorted alphabetically. The standard library API documentation describes methods that vectors, strings, and hash maps have that will be helpful for these exercises. We're getting into more complex programs in which operations can fail, so it's a perfect time to discuss error handling. We will do that next.